Welcome to our webinar today on food waste and biogas, driving the circular economy in Denmark. My name is Chris Voll. I'm the head of Waste Recycling and Biogas Advisory with the Ministry of Foreign Affairs of Denmark. We want to welcome you and thank the New York City Circular City Week organizers for inviting us to be on today. Danish Industries, State of Green, and the Danish Clean Tech Hub. We have a great panel of speakers for you today to talk about an issue that I know is a global challenge for us all, which is how to manage food waste in an effective and affordable way. Denmark, like many other countries in the world, is trying to address food waste and has a national law that in 2023, all municipalities will have to have a program to collect and manage their food waste. In the US, it's estimated that more than 60 million tons of food is either lost or wasted annually. Most of this is going to landfill here in the United States, and we're not realizing the energy and nutrient benefits of that resource. So today we're going to talk a bit about how Denmark has addressed the management of its organic waste streams. More than a decade ago, Denmark made the choice to go to anaerobic digestion and biogas capture as the primary management method. This has allowed them to generate an incredible amount of renewable energy and also capture nutrients for use as fertilizer. So without further ado, I would like to introduce my colleague, Klaus Mortensen. Klaus is the Business Development Manager for Food and Biocluster Denmark. And Klaus will get us started with an overview of anaerobic digestion and biogas in Denmark. Klaus?
Thank you very much, Chris. I'll just see if I can share my screen here. Good morning, everyone. Chris, can you confirm you can see the full screen now?
I can.
Good to hear. Yeah, again, good morning, everyone. My name is Klaus Mortensen. I'm a business developer in Food and Biocluster Denmark, which is the national cluster network within food and agriculture and bioresources. I've been working with biogas for the last around 9 to 10 years, and I'm here to basically tell the story about what have taken place the last 7 or 8 years in the Danish biogas sector. This is a map of Denmark. We are in the northern part of Europe. We are highly intensive agricultural land. We produce three times the food that we consume, and we are highly dependent on having environmental solutions for this intensive and sustainable agricultural production. So we are to some well known for our climate policies. We have a clear climate goal becoming climate neutral by 2050. That also involves using food waste as a resource for biogas and fertilizer. I'll of course get back to that. I think one key aspect here is that we in Denmark have a tradition of working together and we have a high level of trust, which means that universities, companies, and policymakers are working closely together in this small country. So all the green dots here are biogas plants, while the yellow grid is basically the natural gas grid, which goes to Sweden, the western part of Sweden. It goes also to Germany, and we have our own natural gas production in the North Sea, which is west of Denmark. So we are ourselves a gas producing nation. So these, let me just elaborate. Many of you know this already, but I think biogas and biogas production solves a lot of different. It's not just an energy solution for producing renewable energy. It's also an agri-environmental solution for handling waste in different sectors. So this is a really let's say technology that have much more appliances than just energy. I think that's a key thing I have to emphasize here. And the Danish approach to that is that it is a circular economy. We're using waste. We're not using a high level of energy crops that you'll see in other European countries. And we see a high level of cooperation between different farmers, where we also have, let's say, the contract between farmers and biogas plants, where you have this security of supply and also the security of getting rid of the digestate from the biogas plant. But again, Denmark have chosen biogas production as a management strategy for organic waste streams from different sectors, because it plays on many of the different things we do in Denmark, also on agricultural, environment, and energy. So this is basically, we have around 170 biogas plants, and where we've seen the last 8-10 years, the rise is in the co-op plants. So this means biogas plants hauling in 200,000 tons of biomass a year, and up to around, the biggest plants is around close to 1 million tons. So as mentioned, the input we see here is a lot of animal slurry, a lot of different byproducts from slaughterhouses, from other organic fractions from the food industry. And then we see a specific increase of the use of household waste, but also straw. Deeply, it also plays a big role of the input in Danish biogas plants. So this is the rapid development and the biogas boom, some would say, that we've seen since 2000 and let's say 14. We expect by 2023 that around 30% of the gas in the national gas grid will be green. And that again will go to 80% in 2030. And since 2014, almost all new plants are connected to the grid. So this means that we, instead of creating a local energy source in form of heat and electricity by taking a CHP plant at the biogas plant, you create a commodity which is traded in Europe. So you take from a local product to a global product, almost. As mentioned, there's a rise in the use of food waste from private kitchens, and this is just to share basically the value chain as we see it. It's not circular yet, but you have food. It's collected in-house in our apartments and houses in this green, small green bucket, and then thrown in a bin, which is collected by the waste utility, the waste company. Then it goes for pre-treatment. The majority of the food waste goes to a Gimmedan-run plant. And here it's quite important to emphasize that the quality of the output from this pre-treatment plant, which is a pulp, needs to be of high quality. You don't want, the farmers eventually don't want metals, glasses, and all the inorganics on their fields. So I think in order to see food waste as a key for both nutrient management and use, but also energy production and jobs creation and so on, I think it's important to say the quality needs to be at high standard. As you know, there are different products coming out of a biogas plant. You have, of course, the methane, which you have the biogas, which can be upgraded to methane quality, biomethane going to the grid. And that again solves some issues in sectors that you can't really electrify. So we see in Denmark some of the big corporates, the largest energy consumer in Denmark, concrete factory, is going from first natural gas, have just switched from coal to gas, basically. And we see that development, that there are areas, even though that wind turbines and electrification is part of the whole solution, there are industrial processes you can't really electrify. And this is where biomethane is a good solution for that. Another product is the CO2 coming out of the upgrading plant. We see in Denmark that we expect in the development of the future that will be linked with excess wind and solar power, which produce hydrogen, and the hydrogen and the CO2 combined together will produce CH4. So again, biogas and biogas solutions and technologies are a part of a greater energy mix, and it is storable energy, which is something that we need to remember compared to other renewables. And then this is what it's all about, basically nutrient management, which is a key. Around 370,000 tons of food waste was used last year for biomethane production. And just considering the amount of nutrients in this fraction, even though it's a small fraction of the 11.5 million tons of biomass we use for producing biogas, this is actually, it replaces ammonia produced on factories through the Haber-Bosch process, which is consuming around 2% of all energy used around the world. I think that's key, that using biogas and food waste through biogas, food waste otherwise being landfilled, using that to create a nutrient, a product which can be used by the farmer in a safe and highly productive way. I think that's something that we need to emphasize. This is basically a resource that needs to be captured and reused in a circular way. Something that we also have to remember is that biogas is the renewable energy creating most jobs locally per $1 million invested. As an example, this is one of the large biogas plants in Denmark, owned and operated by Nature Energy. It creates economic activity which creates direct and indirect jobs, which correspond to 133 jobs. And this is in a rural area where every job counts. So again, take into consideration that this is a technology that also creates jobs locally. So what's some of the stuff we do in food and biogas in Denmark is related to innovation, R&D, and we are happy to also work with any US stakeholders on that and share our experience from Denmark. One of the projects we participate in on EU level, European Union level, is this value waste. So again, what kind of products can come out of a biogas plant? For instance, the methane can be used to produce protein for feed, or even on a future in the future food. The digestate, we're looking into using that for insect production, again to raise the quality, but also the value of digestate for insect production, which can be used again as a feed for livestock production, which in Denmark are highly dependent on import of soy from South America. The influent, again, can be used into different fractions of fertilizer. We see some of the developments in Denmark saying that the fertilizer is now being customized, tailor-made for specific crops with the right NPK levels. That's some of the innovation we see in Denmark as well. That's some of the things we would like to share with you if you're interested. We've done a report here on biogas production in Denmark on 50 pages on policy, on R&D, and on commercial elements. So I'll be happy to share it. There's also a link here. One of the things we touch upon is the power to X stuff, using hydrogen from solar power or solar or wind, and connecting that to the CO2. There's a lot of R&D stuff going on in Denmark on that topic. Again, we work closely with Chris and Cecilia out of the Danish Foreign Ministry in Washington. There are your contacts in the US, but if you have any questions, just feel free to raise them. Basically, we're happy to take any inquiry. And then the last thing, we are doing another webinar on the 5th of May, where we talk about this economy of scale in biogas production, which is quite also an important aspect to remember, is that by getting larger plants, you get the production price of biomethane down by economy of scale. So that's some of the stuff we'll like to share, and sign up to Cecilia in the email here. So thank you very much, Chris and Cecilia, and thank you very much for listening. I'll be happy to take any questions.
Great, thanks for the excellent overview, Klaus. Much appreciated. It looks like we have one question, and I want to. I may have failed to say this at the beginning, but if you have particular questions, please send them in the question box. Klaus, there was a question related to someone asked, is the biogas clean enough to be put into the grid in Denmark? So if you could clarify that point.
Yes, it is. We actually have a quite high requirement for the gas quality, since the gas quality in the North Sea is quite high. But yes, indeed, it's possible to produce a biomethane with the same specifications as natural gas. One of the technologies we see most is from an upgrading plant, upgrading technology, an amine wash, because there you have also the it's a low pressure process, which means that you don't have the chance of methane slip, because when you have produced biomethane or biogas and you want to upgrade it, you want to make sure it ends up in the grid and not in the air as an emission, because methane is a quite intense greenhouse gas, 21 times more damaging than CO2. So a low pressure upgrading technologies are often used in Denmark for that.
Great, thanks, Klaus. I think we will now move on to our second presentation, and as you can hopefully see on your screen, our next presenter is Lars Nielsen, who's the CEO of Bioeconomy. And we've had already a number of questions on pre-treatment of food waste. And Lars will now make a presentation relative to that. Lars, the floor is yours.
Thank you, and good morning to everybody. And I'm happy to get the opportunity to tell a little about our pre-treatment technology. And as Klaus mentioned before, it's very important to have a good pre-treatment technology if you want to have the best use of the food waste as a source for making green energy and making a fertilizer out of it. Yes. And our philosophy by Gimidan is to provide a system to extract the maximum energy and nutrient benefits from the organic waste sources. And our main tenets are flexibility, performance, and low OPEX. And with flexibility, we mean we can accept any type of packaging. It means plastic, glass, paper, or metal. So our system is also a combined treatment plant and also a deep packing system. Then we want to produce a clean quality biopulp that will maximize the gas production and will provide a high value fertilizer. And then we have a system with low maintenance and labor requirements. And if we are looking at a standard system, you can see below in the right-hand side, we have a feed hopper where you load the waste in, and you can do that either with a front-end loader or with an automatic crane system. And from the food hopper, it goes with a transport screw up to what we call the pulper. And in the pulper, we add water to the waste. And inside the pulper, the waste will rotate. And due to the centrifugal forces inside the pulper, the packaging will be opened so we get access to the food waste inside. And then the food waste will be dissolved in the water during the pulping process. And this is a batch production, and in each batch we have approximately 2.5 tons. And when the pulping time is finished, a valve in the bottom of the pulper will open and the whole batch will go down to the separator. And in the separator, there is a big plate with a lot of small holes where all the fluid pass. That means all the organic stuff. And all the inorganics will stay in front of the plate. And that's the way we separate our inorganics from the organics. When this separation is done, we wash the inorganics twice to also get use of all the fat and similar that's sticking onto the plastic. And then the pulp is transported to the tank for the finished product. And the inorganics goes through a screw press where we press all the water out of it. And this water we will use in the next batch production. And in the end, you have what we call reject, and you can send that for recycling, further recycling, or for a landfill or a waste to energy plant or whatever. And in Denmark, we have currently four plants in operation. The first one is from 2012. And the last one is just opened here by the end of last year. And this plant is receiving the food waste from the Copenhagen area. And this new plant has 2 lines, so therefore the yearly capacity is approximately 120,000 tons per year. Yes. If we look at the system, we have a capacity on 10 to 13 ton of waste per hour. And that means 250 ton per day if you run 24 hours. And if you have more waste than that, we can put in additional lines so we can do a higher volume. The dry matter content in the biopulp is adjustable, and we can adjust it in the range 10 to 20%. If our system is placed just next to the biogas plant, we will typically pump it perhaps with 10% or more. And if it's going to be transported with a truck, we normally have approximately 17% of dry matter, because then it's very easy to pump and it's very fast to load and unload the trucks. And due to the process, the particle sizes in the biopulp are very small, and that allows for an accelerated biogas production. And the system is highly automated with low OPEX, and it's controlled by a SCADA system, which can be operated remotely from an iPad, for instance. And the staffing need is 1 to 3 hours per day, depending on the design. If you have an automatic crane system to feed, you don't need much staffing. And if you have to load the waste manually with a front-end loader, you need a little bit more stuffing. And when we are talking about flexibility, then as I have mentioned before, our system is a combined depacking and pre-treatment system. So during the pulping process, the packaging will be opened and allowing the organics to be dissolved into the liquid fraction. And we have what we call a low impact approach. That means we try to keep all the inorganics parts in big pieces because then it's easier to remove. Some of our competitors, they start to, in the process, to chop the waste in small pieces. And that means if you have a plastic bag and cut that in 100 pieces, then you have a very big, you need very big efforts to find all that 100 pieces and remove them. Our system will typically open the bag and that will contain 3 or 4 pieces, and therefore it's more easy to remove them. And that means also we have a very clean pulp that we supply. And all this means that the system is able to treat and probably manage food waste from residential, commercial, institutional, and industrial streams. And here you can see some examples on the waste we treat in our system. In the left-hand side, I think it's some cheese in metal cans. And we also have some beers in glasses. And even though I have worked with this system here in 5 years, I'm still a little bit surprised that when you put a metal can in the system, then the can will be opened and the food waste inside will come out and will be dissolved in water. But as we will see a little bit later in the video, it works. Yes. And here you can also see some contaminated waste that we receive. As you can see here, the pictures, there is also a lot of non or inorganic stuff in the waste. And now we will show you a video from our plant in Frederikshavn in Denmark. And this plant has been operational since 2019. And here on this plant, there is only one employed, and he make all the works there. And even though, as you see in the video, that it seems very clean everywhere, I can tell you that this video was recorded 6 months after the opening. So it's still, after 2 years now, have the same clean look if you visit that factory.
Gemidan Ecology is a revolutionary technology capable of mechanically converting organic waste into a biopulp that can be used for energy and fertilizer. The system is designed to efficiently receive, process, and get rid of organic waste. First, the lorries cross the weighbridge, where all accessible data about the waste are recorded and stored as documentation as required by law. The system is designed to be able to efficiently handle all types of lorries. The delivered waste is either tipped into the receiving pit or directly into the receiving hall. The system and the technology are designed to be able to handle waste enclosed in all types of packaging: plastic, metal, glass, and cardboard. After this, the process of processing the packaged organic waste begins. The waste is loaded into a feed hopper by a front-end loader. In this system, the feed hopper is capable of operating for about 4 hours, but it can be adapted as required. Once the feed hopper is filled, the automatic process begins, in which the packaged organic waste is conveyed up into a small feed hopper by a screw conveyor. This process helps enhance the efficiency because the feed hopper fills the pulper very quickly. The pulper is a large rotating centrifuge in which waste is mixed with water, quickly dissolving the mixture into a mash-like substance called biopulp. From here, the biopulp is sent to a separator, which separates the inorganic material from the organic material, to send a more than 99.9% pure organic pulp to a storage tank and onto tankers destined for biogas plants. The plants extract the biogas from the biopulp as an eco-friendly, sustainable alternative to fossil fuels. The degassed residual product from the Ecology system is spread as biofertilizer on farmland, thereby contributing to the circular economy. Back at the facility, all the separated inorganic materials have been sorted out. The dry materials are recycled wherever possible. The inorganic material left over can be sent to an incineration plant, which converts your waste and mine into district heating, benefiting all of us once more. Help us to be kind to our environment. It's simply common sense, and green at that.
Thank you. And regarding the pureness of the biopulp, the system was designed to meet the demand of Danish farmers for a high quality organic fertilizer and strict Denmark regulation. The pureness of our biopulp is what we say second to none. And the Ecology system process the only food waste pre-treatment. There's the only food pre-treatment system that has obtained an ETV certificate. And that means a third-party organization can come and take samples and then give you a certificate. And this certificate documents the pureness and the recovery of the potential methane in the waste. Yes. And here you can see some figures from this certificate. In the first line, you can see they have checked some biopulp with 17% dry matter and tested it for all impurities. And you could see the results is 99.96% of the pulp is organic. And if you, please go back. And if you check only for plastic, you can see due to the very low weight of plastic, we have an even higher pureness on 99.96%. Yes. And in the future, we expect that we will get more strengthened regulations for use of digestate as a fertilizer, and then will give us even higher demand to the purity of the biopulp. And in Denmark, we don't only measure the weight of the plastic, but we also have to measure the covered area. That means the volume of it. And all those new regulation in the future is Ecology prepared to fulfill those demands. Yes. And here you can see, it's difficult to see, every month we get an analysis of our production, and that's the results from there. But we will share all the presentations afterwards, and then it's easier to see the values. Next, please. And we also make our own declaration of the pulp from each of our plants. Yes. And here in the certificate, you can also see they have measured how much of the potential methane in the waste you recover in the system. And here you can see that we recover around 95% of all the potential methane in the waste. Yes. And here you can see a picture of an installation we have installed in an existing waste to energy facility, where they have taken one of the furnace out and replaced it with our system. And in the yellow square, you can see the receiving area for the waste. And in the round yellow circle, you can see the tank where they put in the produced pulp. Yes. And here you see a photo of the facility in Frederikshavn you saw in the view in the video. And here you can see in the right-hand side, we have a lagoon where we collect surface water from the area. And this surface water we use in the production. And here we have the latest facility near Copenhagen with 2 lines, and that's look like the other one, that you have a building where you store all the incoming waste, and you have in the front around a concrete tank where you store all the finished pulp. Yes. And if you need more information, you can go to our website to see it, and you can also send an email to me directly. Then I'll try to answer your question. Thank you very much.
Thanks, Lars. Appreciate that. I think there are some questions that have come in. Lars, I would ask while the next presentation, if you could try to answer some of those online, that would be great. To keep on time and make sure we hear all of our presentations. Want to next invite Paul Einer Rasmussen, who's the CEO of Renew Energy, to talk about how some of the technology and expertise from Denmark has been transferred here to the US. And Paul is going to tell us a bit about some of their experience and specifically the Trenton Biogas project. Paul Einer, over to you.
Thank you. Thank you. I will be there. And if Cecilia will try to push forward the presentation. Great. Yeah. Basically, we are dealing with biomass, various kind of biomass. I mean, it can be manure, it can be food waste, it can be liquid, it can be stackable. That's our input to the system. Anaerobic digestion, which is what we are dealing with, is a system of multi-step, let's say, processes. And some part we are doing hydrolysis. We are then going into a kind of acidification. Then we're going to the next step. And finally, we are going to the methane production side. So it's a complex system, much more complex than other kind of, let's say, biological process, such as brewing beers and whatever it is, But so we need to know exactly what is going on in the process and what can inhibit the system. That's why we are always looking at the biomass type on analysis of the content, and then we can do a mass balance, and the mass balance will tell us how the process will work, and that will again give us the design parameter for a biogas plant. Yes, please. The output will be biogas, and it will be, let's say, digestate to deal with. We try to explain that the biogas system is a catalyst in circular bioeconomy. We have we have on our land side, we have our ecosystem where we are producing food materials, which goes into the city who are processing it, eating it, and at the end there will come bio-waste from both sides, bio-waste from the food industry, there will come bio-waste from farms, and it can go into anaerobic digestion together. We call it, and we can do co-generation, co-digestion. Digestion will produce biogas, and it will produce nutrients, which can go back to the farm. We can recover nutrients in a form which will be needed, or we can land apply it directly, which are common use here in Denmark, but it's not always. We do have land available, and then we need to do a further processing. I will come back to this a little bit later. Biogas can be treated and go up to be used either as a biomethane, or it can be used to fuel gas engines to produce power and heat. Yeah. Bioeconomy or circular bioeconomy. I will try to say which kind of low-hanging fruits can we deal with. We do have household organic waste, we do have industrial organic waste, and we have agriculture waste. It's again a resource for producing energy and nutrients. We are producing biogas as a clean biofuel for heat and power production. We are producing biomethane as a green substitute for fossil natural gas. And I would say I was a question about the quality of biomethane. It's absolutely the same quality as natural gas, even cleaner, because it has no higher carbon, it has only methane. And it can be used just as natural gas. There are specific restrictions on how clean it should be, and we need to have it up to 98% methane. We need to have almost zero sulfur in. We will not accept to have any CO2, only limited, and we will have no acceptance of water in. And oxygen are not seen, so it should be less than 0.2% or something like that. Water can, yeah, you are a little bit so fast, and then we have the other side where we have the carbon. We have nitrogen, which are useful as a fertilizer, as a fast-growing fertilizer. We have phosphorus, and we have, of course, potassium. All the ingredients we need to have for a successful farming. Yeah. A very simple system here is, and that was where all started with biogas. It was slurry from farms. It was preheated up to a temperature about either mesophilic as a 37°C or thermophilic as 52°C. It was mixed here. Most importantly is that we have a good mixing, a good temperature control. then we are producing biogas. Biogas will contain sulfur, hydrogen sulfur. It needs to be cleaned in order not to destroy the gas engine when we're producing power and heat. And then there will be a digestate which can go on storage and then for land application. Then we can do it a little bit more sophisticated, as we are very often dealing with co-digestion. So it's not only farm waste, it can be some other type of organic material, solids. So we need to have a pre-mixing in order to have a condition for the feed going into digestion, which are homogeneous and pumpable and mixable. Yes. When we have the biogas produced, we can go two ways. One is to go to produce heat and power, desulfurization. Next is to do gas upgrading. And there are several technologies. Here we can have a water scrubbing, we can have pressure swing absorption, we can have amine scrubbing, and we can have membrane system. Here we have shown an upgrading using amine scrubbing, where the amine will absorb the CO2 and the hydrogen sulfur. It will then, when we are then recovering the amine, we will release CO2 and we will release hydrogen sulfur. It has to be cleaned afterwards in order to have a clean environment, and we will have a clean biomethane to the grid. Yes. Per tradition, in Denmark, we have delivered all degassed material, or so-called digestate, back to land as a liquid fertilizer for land application. We can also do a mechanical separation here in order to have a even more liquid here, and we can have a solid fraction also as a fertilizer. Yes. When we are dealing with food waste, we need to have a pre-treatment system like the one you saw from Gimmidan, which is excellent, because again here, when we have the input here, and here, it should be almost the same quality. It can be from 5% to 7%, 70% solid, but it has to be homogeneous, it has to be pumpable, and this is what we get if we are using this pre-sorting system as we have at the Gimmidan. We also need to have, we call it sanitation, because according to EU rules, we need to secure that no pathogen bacteria will pass through the system. So we have by law saying that we need to have a pre-treatment in 1 hour at 70 degrees C in order to be sure that it's absolutely pathogen free, which goes in here and which goes further on the land. Yeah. We can not always rely that we have possibility for land application. So we do have technology, have a patent where we can recover ammonia in a stripping process and then absorb it in sulfuric acid as ammonia sulfate. We can also, a little bit back, and we can also clean the effluent further up in reverse osmosis and produce a processed water. There will be some fertilizers coming in here, and we will go up to having a solid fertilizer as well. This is what we call a complete biorefinery. And that's what we actually have built in Trenton, New Jersey. Next, please. In Trenton, New Jersey, there is a site where our system is built in. It's treating 300 ton food waste per day, 300 to 400 tons per day. There is a power production of 3 megawatt. It's start construction in 2018, and the first part was commissioned end of 19, but there have been continuously increased capacity for food waste, and so we are almost there where it's working completely. It's placed next to a wastewater treatment plant, and the effluent after digestion has a quality which allows us to deliver it back to the wastewater treatment plant, and there are no land application. Yes. So again, we have a pre-treatment, a depacking system, and there are additional industrial waste coming in to the digester. We are producing biogas. We have a desulfurization, have a gas holder, gas engine, which produce heat and power. And then the digestate goes firstly into a mechanical separation in a so-called decanter centrifuge, where we are producing biosolids, and we have a liquid which are processed in ammonia stripping, and we are taking ammonia out as ammonia sulfate, and we have effluent which are delivered back to the wastewater treatment plant. Yes, please. There are pictures about the plant. There are 3 digesters, each of them 5,000 cubic meter. There are decanter centrifuge, gas holder, ammonia stripper. Yeah. This is another plant in Denmark, Monsoon biogas plant, which are the biggest plant for organic material, and it was partly consisting of could take liquid manure, it could take solid feedstock, which are pre-mixed, and it goes into a digestion where we have co-digestion of various feeds. We are producing biogas. Biogas goes into a gas upgrading and desulfurization, and the gas is delivered to the gas grid. Digestate goes back to farmer again. Yes, we have our office in Denmark. We are doing development, design, and service for biogas and biorefineries projects. We have a couple of projects in US, one in Michigan built 9 years ago. We have renewable energy, Trenton Biogas, which are been in the process for a couple of years, and then we have a few other projects coming up right now. Yes. Thank you.
Thanks, Paul Einer. Excellent presentation, and thank you for doing that. I think I'm not sure I saw any particular questions, Paul, right at the moment, related to your presentation.
If there will come any, just let me know. Yeah.
No, I did see one. Someone was asking about where the ammonium sulfate, Paul, is ending up from the Trenton project.
It's going to a fertilizer company who are selling it as a part of their portfolio of nutrients. I know that it's excellent for golf courses, for sure. But it's also excellent as a starter fertilizer for growing corn.
Great. Well, here's another one I'll put to you, Paul. I think we only have maybe a minute left here, but they're wondering about what may be some of the major barriers to anaerobic digestion and biogas plants in North America.
Major barriers, as we see it, of course, there is some traditions in the past, especially from the farm industry, where anaerobic digestion was not really seen as a very efficient system, but was seen as just a way to get permit to build a new dairy barn. So probably quite inefficient digesters, and we are more for, we call it, high efficient digesting system with high recovery and low methane loss. I think one of the barriers is also financing. The Trenton Biogas took a long time to finance, and finally we have a cooperation with Danish Export Credit Foundation, who offered loan guarantees in order to secure banks for any risk. And I think that was very efficient, as we have traditions in Denmark, and EKF knows that we have technology, whereas in US banks were conservative and a little bit scared about going in. So I think this is a way we think we will go also in the future, and it's an offer they still have to work with.
Great. Thanks, Paul Einer. And I think, unfortunately, as always, we have run out of time. I know there has been a lot of questions. I think people have answered those for the most part online. One of the questions that came up multiple times was, will the biogas report, can we share the link? That was shared within the chat or in the Q&A. So invite you to look that up. We will also make the presentations available. I'm going to see if I can share real quickly here my screen. And there's contact information here for each of the presenters that you heard today. With that, I think we will close the webinar. Again, I want to thank you all very much for joining. We have huge challenges in front of us here in the US relative to food waste management, as well as around the globe. And we look forward to working with some of you and some of the expertise from the Danish companies and Danish organizations to help address some of those issues.